Welcome back to Basic Advanced Math, the channel where I take more complex math concepts and try to explain them to you in a way that you can understand so that you can get this stuff down. It's important if you're trying to pass. Today, you're still on Calculus BC or Calc 2. They're the same thing, doesn't matter what you call them, and we're talking about L'Hopital's rule. This is fundamental to Calc BC. It's the basis for a lot of the stuff you're going to be doing. You're going to be doing a lot of manipulation with it. But anyway, let's get straight into this. Let me tell you what L'Hopital's rule exactly is. So basically, L'Hopital's rule says that if you have a limit as x goes to infinity, we've dealt with limits before, we know what they are. If you have a limit as x goes to infinity, say of x, let's say x cubed over 4x cubed. You have this limit, you want to know what it is. Well, the problem is we can easily see that as x goes to infinity, it'll be infinity over infinity. It's not for infinity because that's not even a thing. It's just infinity. How do we solve this? This is where L'Hopital's rule comes in. So this would be infinity over infinity. This is a good form. We like it like this. This is where we take L'Hopital's rule. L'Hopital's rule says that if a limit to infinity equals either infinity over infinity or if it equals 0 over 0, what we can actually do is just take the derivative of both the top function and the bottom function separately, and we have the exact same result. It's going to equal the exact same thing. So now what we're going to do is we're going to take the derivative of both the top and the bottom. We're going to say it equals, what is that? 3x squared over 12x squared. What does that equal? Once again, you plug in infinity to both x's, it's going to be infinity. We're going to do it again because it equals infinity over infinity, which means that we can apply L'Hopital's rule, take the derivative of both the top and the bottom, apply it again, we see what we get. We're going to get 6x over 24x. We're getting close. We're getting closer. However, this is still not the answer. Of course, if we plug in infinity, we're going to get infinity over infinity. We got one last step. We do it again. It equals 6 over 24. We take the derivative of the top, the derivative of the bottom, put them on top of each other, we can take 24ths. And so the limit of this equation was 6/24, which equals 1/4. A little shortcut, if you have both of them, and these are your only terms that you have, just a simple cube and another simple cube, what you could have actually done from the beginning is divide both the top and the bottom by x cubed. You get 1/4. It's equal to that. Either way works. However, as we get deeper into L'Hopital's, it's important to know what it is because in the future you're not going to be able to just divide. This is the basics for L'Hopital's. This is what it says. The same thing would apply if we were going to 0. Say we go to 0, then the limit is going to equal 0 over 0, right? Limit to 0, x cubed over 4x cubed. It's going to equal 0 over 0. It's not 4, 0, it's just 0. Which means that we can take L'Hopital's rule in the exact same way. We get this, it's still 0. We get this, still 0. And we go down to 6/24, which equals 1/4. And that's the basic L'Hopital's. You can only do this if it equals 0 over 0 or infinity over infinity. That's all it is. This is where we start. Now we're going to start getting into more complex stuff, and this is where it gets crazy. This is where you're going to have to start learning your stuff. So let's go ahead and let's get straight into that. The next form that we're going to be talking about is if you get it in 0 times infinity or infinity minus infinity. The example that we're going to be doing is, as you can see, right here. It's going to be the 0 times infinity form. Why is that? It's the limit as x goes to 0, which of course x as it goes to 0 is 0. The natural log of x as it goes to 0 is actually negative infinity, which we can count as a positive infinity. It doesn't really matter. They just write infinity. So how we're going to do this, we get 0 times infinity. How are we going to get this into the form that we want it, which is of course 0 over 0 or infinity over infinity. We'll see this. That's our answer. That's what we get right here. We always want to try and get it into 0 over 0, infinity over infinity. That's the main goal. That's the only way you can use L'Hopital's rule. So we have to use algebra to get it into that form. What are we going to do? We're going to take this x and we're going to divide the entire equation by x, which means multiplying both the top by 1 over x and the implied bottom over 1 by 1 over x. So what are we going to end up getting? We're going to come right over here. We're going to get the ln of x over 1 over x. This looks kind of confusing. It seems a little bit strange, but it makes it so much simpler. Now, as you notice, we plug in 0 into the formula. We get ln of x, which is 0. We get infinity, or minus infinity. It's the same thing. Now the bottom, we count this right here, 1 over x. We count that as one term. We can do that. We're going to do that because it makes everything so much easier instead of trying to figure everything out all lined up like that. So 1 over 0 is, of course, infinity. It's pretty much common sense. So now we have it in the form of infinity over infinity. Now what do? Of course, we have it in the right form. Now we're going to simply apply L'Hopital's rules. Let's come back down here. What is the derivative ln of x? As you already know, it is the x prime over x, which is simply 1 over x. We're going to throw this down here. 1 over x. That is the top. What is the bottom? What is the derivative of 1 over x? We're, of course, going to get minus 1 over x squared. Not that difficult. Minus 1 over x squared. This might look like it's kind of difficult, and it is, really, because we don't know what we're doing yet. However, if we were to put this in a simpler form, we're going to rewrite this in a way that you can more easily understand it. We just flip this up top, and we end up getting negative x squared over x. As you can see, you simply divide both the top and the bottom by x again. We're left with minus, well, that's not an x. That was a straight line. You get minus x. You plug in 0 to minus x, you're going to get 0. So the limit as x approaches infinity of x times the natural log of x is 0. This is your final answer. This is more difficult than the first one because you have to use algebra to get the final answer. In the next video, we're going to talk about a form up here that is more difficult than this one, but it's the last one that you're going to have to know. Now, you know what, guys? Forget a 2-part video. I'm not going to do you guys like that. Let's go. We're going to get this last example right here that we got up on the board. We're going to kill it, and we're going to be done with L'Hopital's. The last situation that you're going to need L'Hopital's in is when you have it in these 3 forms, exponential forms. You're going to either have 1 to the infinity, 0 to the 0, or infinity to the 0. All 3 of these situations are cases where we need to use what I'm about to show you to find out what the limit is. So, starting off, we're going to go straight into an example so we can get this done, so we can get this out. I'm not going to try and confuse you guys or anything. I'm going to try and put it as clearly as possible, all right? Say we have the limit as x approaches 0 of x to the x. What is that going to be? As you can see, 0 to the 0. How do we define 0 to the 0? We don't know what it is. It could be anything. So, what this form tells us, if it's one of these 3 examples, then we know that we can rewrite this using the natural log and the e. This is going to be very weird at first until you get used to it. Actually, those 2 cancel each other out. When you put e to the natural log of something, it's like it never existed. However, it makes this equation much easier to solve, and we can use L'Hopital's with it. So what we're going to do is we're going to rewrite this equation right here. We're going to rewrite it as e to the natural log of x to the x. We rewrote this. E and natural log cancel each other out. So this is the exact same as this. We just rewrote it in a different way. However, we can simplify this even more by realizing that natural log of x to the x is the same thing as x times the natural log of x. It's one of those log rules that we have that can make everything so much easier because we know how to manipulate it to do whatever we want with it in a correct way. So we're going to bring this down. We're going to worry about just this right now. After we have it in this e form, we're going to worry about just finding the limit as this approaches 0. And then we're going to plug it back into the e and figure out what the final answer is. So what we're going to do is we're going to take this, however, we're going to put it in simplified form. So we're going to have x times the ln of x. Now here's where we are. We have this. Where do we go from here? Oh no, we've seen this before. We saw this just in the last example, and we know what to do because we just solved this. This, as x goes to 0, is 0, of course. This is negative infinity, aka infinity. So we have 0 times infinity. Let's write that out. Of course, we know what to do from here. We need to use algebra to get into the form that we want, which is either 0 over 0 or infinity over infinity. Let's go ahead and solve that. It's the exact same thing as last equation, so we know what it is. It is going to be dividing both sides, both the top and the bottom, by x. So we're going to end up with this. We see we have this equation right here, and as x goes to 0, we can see that ln of x will still go to infinity. However, 1 over x will also go to infinity. So what are we going to do? We're going to write infinity over infinity. Now that we have it in the form that we want, what can we do? We can use L'Hopital's rule, take the derivative of the top and the bottom functions, and then go from there. So let's see what that takes us. Like I said, it's the exact same problem as last time. You should recognize this. You should also recognize that this simplifies to simply minus x. And as we obviously know, as x approaches 0, we know that minus x is going to be 0. That's all it is. So this is where most people get messed up. They're going to say, okay, the limit as x approaches 0 is 0. My final answer is 0. You cannot do that. You cannot be caught sleeping on these exponential equations. What we got to do now is we got to take this 0 over here, and we got to bring it back up here to where the e is. So now we're going to say the limit as x approaches 0, which we've already plugged in. Now we just have e to the 0th power. And of course we know any defined number to the 0th power is always going to be 1. If you don't know that, get that in your mind. So what do we have as the final answer? We have 1 as the final answer. That's it. That's all you need to know. Any of these three forms, you're going to do that. Put it into e, solve for the exponent, plug it back into e, and you're done. You're finished. You beat the problem. You won. So you cannot forget to plug it back into the e. I cannot tell you how many times I've done that. I was like, oh yes, I just killed this problem. I checked the answer. I forgot to plug it back into the e. If you plug it back into the e, you should be good. Everything goes. I believe in you guys. This is all you got to do. We're done with L'Hopital's rule. This is the basics. Everything else is just evolving from this, and we're done. Finally.